Hey guys, and welcome in this new Blockledge video. In this video, I will give you a full introduction to blockchain technology. After watching it, you'll know what it is, how it works, what is a block, what is a chain, etc. If you don't know who I am yet, my name is Amare Amapakabo, and I am the CEO and co-founder at Blockledge. Blockledge is a blockchain education platform that allows you to learn everything there is to know about blockchain, from the basics to more complex things. And there you can learn, test your knowledge with quizzes, and basically progress and earn as you progress. The video that you're gonna watch is actually extracted from one of our courses on Blockledge. So if you want to learn more, just go there. There will be a link in the description. For now though, let's get to the video. The first thing we're going to talk about is what is a ledger, and you will understand why in a second. The second thing we're going to talk about is making blockchain immutable. Then we'll talk about hashing, the block, the chain, distributed, and finally, blockchain is. You'll get the answer at the end of this video. Blockchain is a ledger. Now, if you don't know what a ledger is, well, let's just imagine that I have a notepad in which I put every transaction that happened between I and my friends, and I'm the only one that has the ability to put things in this ledger. So for example, let's say I go and eat with my friend Maxim and he pays for me. So I could enter in this ledger, Maxim gave Amari $10. So in the future, I could go back in this ledger and check what I owe to Maxim, what amount. Let's say that then I go and eat with my friend Anna and I pay her a coffee at Starbucks for $5, right? So I write it in my ledger. I say Amari gave Anna $5. And whenever I get a new transaction going on between I and my friends, I'm basically gonna write this transaction in the ledger. So Michael gave Maxim $20, etc. So that whenever I need, or my friend need to know what they owe to who, they can refer to this ledger and basically check who paid what to who. The two major problems with this way of tracking transactions are consensus and trust. So basically, consensus in this case is what transactions actually go in this ledger. How do we agree on which transactions are written in the ledger, and do we actually agree on the validity of the data that is written in this ledger, right? So that is consensus. And trust, can we actually trust the transaction history, which is my first transaction, right? So let's say this first transaction, can we actually trust that it was $10 and not, $100? Because if I wanted to, I could go in and add a zero. So this way of tracking data with a paper ledger is pretty much useless because there's no way to track these things. So with blockchain, we come in and we say to make sure that we trust the transaction history, we need to make the data immutable. Immutable means that the data cannot ever be changed. So whenever the data is entered and validated, there's no way to come back and change it in any way. And to do this, we could use encryption. The most simplified version of encryption is the Caesar cipher, which is an encryption model that Julius Caesar invented so he could send letters to his allies without risking that his enemies would read the letters. He invented that simple encryption model that just consists of shifting the alphabet of a set number of letters. So I will show you a live example of what that would be. So here I am on this Caesar cipher demo, and basically you can see I have a text input here, and I also have a shift number, right, of 4, and I have a ciphertext, which is basically the results of my shift. So let's say I want to say hello world, something very simple, and I click on encrypt, and basically it's going to take this input here and it's going to shift all of the letters by 4. So basically, instead of having hello world, we're going to have lips as vap, right? And if I put 11 here, it's going to do the same thing. It's going to shift the letters by 11. Now, the problem of this type of encryption is that it is easily decryptable if you have the deciphering key. So basically, if I'm Julius Caesar's enemy and I know the number of letters by which he shifted the alphabet, I'll be easily able to read the message that was sent to his ally. So that's why we cannot really trust this type of encryption to secure our data in blockchain. Instead of using encryption, we can use hashing to make our data completely immutable. Hashing is basically encryption on steroids. So instead of having a simple encryption pattern like shifting the letter by 11 letters, we have something that is completely unpredictable in terms of what results you're going to get from the data. Basically, hashing is an algorithm in which we put our data and then it's going to mix a bunch of things and is going to give you a hash that is completely unique each time there's a new entry. Unlike encryption, hashing makes it almost impossible to decrypt the original message. So that means that in our ledger, whenever we enter something, nobody could come in and see what was originally written. Hashing also provides a hash that is always the same length when using the same hashing algorithm. So I will show you a demo after, and in this demo, the length you will see will always be the same regardless of what I type in. One great thing about hashing as well is that no deciphering key exists. So you can't say, oh, I think the deciphering key is 4 and then shift back to get back to the original message. This is only real with encryption, but in hashing we don't have any similar concepts. The last thing that makes hashing so great is that once the data has been transformed, it cannot be returned to its original state. So I'll show you what hashing does. So here I am on the demo of the SHA-256 hash, which is a hash algorithm. So as you can see here, if I type hello world, my hash is something completely random. So there's no way to actually know what it means. And the crazy thing is that you will see why it's so cool. But if I just add a space here and an exclamation point, my hash is completely different. So you can see that there's no encryption pattern at all. So it's not like my letters here mean something here. It is always completely, it's not random. I mean, it's like an algorithm, but there's no way to guess what it's going to be based on what we have here. That is so great because it allows us to never be able to alter the data whatsoever. The second great thing that I want to show you is that whatever I type in here, so in my input, you can see that my hash is always the same length. Even if my input is very long, it's always going to be the same length, and that is also very useful, and you will understand why in a moment. So that's great, that's fun and all, but how does all of this apply to blockchain? Well, each entry in the block is called a block, and basically a block in the blockchain is exactly like a page in my paper ledger, so my notebook, right? So each page of my notebook is basically going to be a block in the blockchain. That's the best way to think about a block. So basically, if I take my page here and I make it blockchain mode, that's what well, actually not that, this is not the same block, but this is a block in the blockchain, right? So you can see each block has a nonce, and you'll see what it means after. And it has a hash. And basically, all of the transactions that you see here are represented by this hash. Each block has a unique hash, as I just said. So here I am on my blockchain demo again, and you can see that I have a block in the blockchain right here, right? But I only have one block, so it's not a chain, it's just a block. So you can see I have my nonce, as I just showed you, and I also have my data here, which are going to be all of my transactions. So instead of writing it in a paper ledger, I would write it here. So Maxim sent Amari $10, Amari sent Anna $5, etc. That would go in this data here. This, we will see what it is after, and I have a hash here. So basically, you can see that whatever I type here, my data, whatever, like we're just going to type whatever, I have a different hash all the time. And you can also see that my block turned red. Why? Well, it turned red because my block is not valid anymore. So basically, validating a block is me being able to add my block to the blockchain. That's what validating a block means. And to validate a block, we need to do this thing called mining. So because blockchain is an open network, and we will see that after in the distributed part, not everyone can add a block whenever they need to, right? Because if yes, it would be too easy to add a block and everybody would get rewards all the time, because basically miners get rewards whenever they mine a block, right? So if it was too easy to mine a block and to add a block to the blockchain, everybody would do it and everybody would make a lot of money doing that. So to solve this problem, there are some rules that we need to respect for a block to be added to the chain. And if I enable my expert mode here, you can see I have something called block difficulty. And the block difficulty is basically how hard it is to mine a block. In this case, it's equal to 4 zeros. So that means my hash has to start with 4 zeros in order to be added to my blockchain. So now you might ask yourself, but how does it work then? Because we have the data here, and whenever we change the data, my hash changes. And we also have a block number, and if I change this block number, my hash also changes. So you can guess that it's not by changing the data or the block number that we're going to find our hash that starts with 4 zeros. And that's why we have this thing here called a nonce. And basically, a nonce is what we call the proof of work. The proof of work is this little number that a computer needs to find in order to validate a block to be able to add it to the blockchain. So we could go and do 1, 2, 3, 4, 5. Well, we could basically go through all of the numbers until we find one that makes our hash start with 4 zeros, but this would take a lot of time. And that's why instead the computer basically does it for us, right? So if I click on my mine button, my computer is going to go through all of these numbers until it finds a number that makes our hash start with 4 zeros here. And here you can say that my block is valid again. This process is called mining. And that is exactly what it refers to when you hear Bitcoin mining or Ethereum mining, although now Ethereum mining is not really a thing anymore as it used to be because it changed. We will have a course, by the way, that covers all of the different proofs in blockchain, because this way of validating blocks in the blockchain is called proof of work. But there are some other proofs like proof of stake and a bunch of other proof of something. So we'll have a course that basically talks about all of the different ways to validate transactions in a blockchain. So that was exactly how a block in the blockchain works. So once again, you have a block number, then you have a nonce, which is the number that corresponds to the proof of work that miners need to find in order to add it to the chain, which is what we're going to cover right now. Then you have all of the data of the block and a hash that represents basically the block itself. Now, we know about block, but what about the chain part of blockchain? Well, the trick is that each block in the blockchain contains the hash of the previous block. And that is exactly the magic of blockchain. So as you can see here, basically each of my blocks here, block number 1, number 2, number 3, and number 4 are linked to each other because each block contains the hash of the previous block in its data. You can see that block 2 contains the hash of block 1 in its data. So that means that if the hash of block 1 changes, the data of block 2 is also going to change because it is contained in the data of block 2. So it's also going to change the hash, which in turn is going to change the data data of block 3, etc, etc. And I will show you a demo of this right now. This is honestly a very important concept to understand. So here I am on my blockchain demo, and so you can see I have all of my blocks here, and if we take our prev input here, you can see that this corresponds to my hash of my previous block here, right? So it starts with 4 zeros and then 7F927. So that's what we have here as well. 4 zeros, 7F927. So let's try something, okay? Let's take our block 3 and try and change the data. You can see that immediately all of the chain that follows is invalidated, is turning red. And as I explained before, that is because the hash here changes the hash here as well. And because this hash is contained in the data of this block, it's also going to change the hash here, which is also going to change here. And so basically, that's how we can make sure that nobody ever tries to cheat in the blockchain and that nobody can ever change anything in our transaction history. So there are two things that come into play to make sure that our data is immutable. The first thing is hashing, and the second thing is the fact that each block contains the hash of the previous block in its data. So as I just demonstrated, changing the data of only one block would basically invalidate the whole chain that comes after. So that's great, right? We are done. Like, blockchain is secure. That's so great. No, there's still one thing we need to do. Because basically, if I go back on my blockchain here, if I was the only one that is managing this blockchain, I could still change the data here and say, for example, Maxim gave Amari $100. Right? And then I could still be able to mine each block, right? It would take a while, especially if it's a transaction that was a while ago, but potentially this could be possible. And that is why blockchain is also distributed. Basically, that means that whenever there's a new block added to the blockchain, the new state of the blockchain is copied over to every computers in the world. That means that I will have the exact same blockchain as you on my computer, and we'll have both the same blockchain as someone else, and etc. Everybody has a same blockchain that is copied over to the blockchain network that you can access through your computer. So here again on my website, you can see that here I have peer A, peer B, and peer C here, right? And you can see that each of our peers have the same blockchain. We can see that in many ways, but one of the easiest thing to see that is with this, right? The last block hash is equal to 4 zeros, A7, D, E, F, F, etc. Here's the same 4 zeros, A7, D, E, F, F. And here again, 4 zeros, A7, D, E, F, F, right? So that means that each of these peers here have the exact same blockchain. So now, if I'm a bot player and I try to cheat in the blockchain network and basically change the data, well, I can try to do that. But then you realize that my blockchain doesn't look like anybody else's. Right? My last block hash is equal to something that is not even valid anymore. And let's say that I mine, once again, all of my blocks in my blockchain. Well, you can see that I have a completely different last block hash, right? So it's equal to 4 zeros, D, E, 0, 8, F. But if I compare it to my two other peers, they still have the exact same hash. And that's how we can actually spot cheaters in the network. So basically, all of these things that I showed you, they solve the problem that we saw at the beginning, which were consensus and trust. Blockchain solves consensus by adding a difficulty level to the blockchain. There are some set conditions that need to be met in order to to add a block to the blockchain. And that is the concept of proof of work that I showed you earlier. And trust is solved in many ways, right? So we have the hashing that is basically used for consensus as well, and also for trust, because each block in the blockchain has the hash of the previous block in its data. So that means that if someone tries to change the data, it will be easy to spot that blocks are not valid anymore. And the last thing that solves this trust problem is the fact that blockchain is also distributed, because if I try to cheat but you don't and your other peer doesn't, well, you'll be able to easily tell that I'm cheating because I have different blockchain than you both. And that is exactly how we can make sure that each entry in the block can never ever be changed in the future. So I know you've been waiting for that, but to resume all of what we saw, we can say that blockchain is a distributed digital ledger that is made immutable and secure thanks to cryptography. And you might understand now that blockchain is great for all of these reasons, but also for these, right? Blockchain allows the storage of data that is made completely immutable thanks to cryptography, the distribution of copies of the blockchain to every computer. Blockchain also removes the need for trust in a single third party. And that's because it is a network and there's not one person basically saying, yes, this goes in the ledger or not. It's basically like a whole network that had some set rules and that everybody has to respect in order to participate in. Blockchain removes cheaters from the equation. And finally, blockchain is completely decentralized. All right, guys, so that is the end for this video. I really hope you liked it. If you did, leave a like, subscribe, and leave a comment. That really encourages us to make more videos like that. Once again, if you want to learn more about blockchain, earn prices as you progress, and all of that, you can go to blockledge.xyz. There will be a link in the description that goes directly to our website where you can sign up. That was all for me though. I hope to see you there, and I'll see you in the next video. Cheers.